Hey guys, welcome to the second video of this playlist. And today we will talking about what is a block, what is a chain, and hence what's a blockchain, nodes, and miners. These are very basic building blocks of this entire blockchain thing, right? So just we will go through each and everything of it. Now, starting with, before starting with this, if you haven't went through the last video, which is bit lengthy, 47 minutes, but that explains a lot of basic things. I mean, that will also be used, that logic or the terms that I have used there will also get used here. So I would request you, if you can, please go through that. From now, I will try to keep videos very short, let's say 10 or 15 minutes, so that the engagement remains, right? So yeah, what is a block? So see, first of all, let's talk about what or how a transaction is done. Okay, let's talk about how a transaction is done. Why? Because how a transaction is done will clear all of this point one by one, right? Let's start with this. So I will go and how a transaction is done. Correct. Cool. Let's understand this. So let's say you are on a platform. Let's take a real life example. You're on a platform, and for example, very bad example, but let's say you are on Binance. Okay, so we have a Binance platform, right? And let's say if you are a developer, you might be also already known of this term called server. So there is a Binance server, right? And you you would definitely have something called Binance frontend, correct? Binance FE. Okay. Now, so what will happen from, let's say here, from here you did some clicks, right? From here you did some clicks, and what happened? You did ask that, hey, send. So okay, let me do this. Okay, let's delete this up. What did you say? Send one BTC to, let's say, Tejas. Yeah. So what did I say to this Binance frontend? That hey, send one BTC to Tejas, right? So they in Bitcoin network, I would say, or anyone is not known by their name. Everyone is known by their public address, right? Public address, that means there's a let's say, for example, let's say there's a storage, right? As of now, let's consider it like this. There's a storage, and this storage has two things. This storage has two things. The first thing is it has a public address, cool, and the second thing, it has a private address. This is nothing but consider your wallet. Okay, for as of now, consider your wallet. This is your wallet. Okay, wallet, and this wallet has a public address and a private address. What if you own this? See, okay, if you own this, no one, I mean, with the help of this, you can send or send money. Okay, you can do transaction with the help of this private address. But if you share, but you need a way to link to this wallet, so that people can only send money, but they can't send money. Send money to you, not send money out of your wallet. So for this, this public address is created. Okay, I hope you got this. So the public address is something we send it to people, right? We send it out to the world that, hey, this is my address. If you want to send money to me, send it to this public address. If I will send money to you, I will use this public address, this my private address. We will come back to this, how this private address, in the same video, how this private address is used. I hope now this makes sense. Cool. So let's delete this up as of now. Yeah. So now I hope you got the hang of what is public and private address. So Tejas, first of all, Tejas might also have a public address which is pointing to his wallet, and I might also have, I mean, I not might, I also have a public and a private address. But if you do remember, the sender uses his private key, not public key, to send money. Only private key can be used to send money. The public key can only be used to receive money, and for other various stuff, don't worry about that as of now. So whenever in Binance front end, I say send one BTC to Tejas, this message goes to the Binance server, right? This message goes to the Binance server. What Binance server does? Binance server, nothing but, so this is the starting point of entire blockchain transaction. Cool. Just have a look here. What this Binance server does? This Binance servers create a structure. Okay. What does this Binance server do? This Binance server creates an object structure. What this object structure includes is the question to ask, right? And this is the entry point to the entire Bitcoin transaction. First of all, this thing includes, this is Binance server, okay? This Binance server already has your public key, okay? This Binance server has your public key. I mean, see, Binance is a very bad example here. Binance can't be used to send the money. I'm just giving an example here. You use wallets. But yeah, Binance, for now consider there's a Binance server that has your public key. Sorry, public and the private key. Please do remember, private key can be used to send money, public key can be used to receive money. Okay. So now this Binance server creates an object. This object consists of the following thing, right? It includes the senders, which is mine. I would say, let's say test public address. Cool. This includes my public address, that hey, this guy with this public address. Please do remember, private address is never sent in the public, in the network. If you give your private key to anyone, private address to anyone, he has whole access to whole of your money. Okay, he has the entire access to your wallet. He can take out the money anytime he wants. So the Binance server creates an object that has a senders, which is my public address, right? It also has receivers public address. Let's say the receivers is nothing but pages public address, right? Now, after this, what also it has, we will look into this, why all of this is getting used. What it use is the transaction amount. Let's say 1 BTC, right? I'm transferring, I have a lot of money, I'm transferring him 1 BTC. Now, after this, it also has a transaction fee. Transaction fee is something that is used in the network. How it gets used, we will come back to this later. After this, it has a timestamp, right? It has a timestamp that at what time we are sending this money, and it has a signed message. It has a signed message. Now, what is this signed message? If you ask, what is this signed message? Correct. So first of all, consider these all data. The Binance server creates an object that has all of this data. Cool. This Binance server does this. Now, if you are not aware of what is signed message, you can skip, let's say, 1 or 2 minutes here. I will try to explain to people who don't understand, right? First of all, I would also like to request you to have a look on the previous video that has explanation of what is an hash, what is an encryption, okay, and that will get used here. Signed message, what happens is nothing but this, all of this data, which is sender's address, receiver's address, right? Sender's address, receiver's address, transaction amount, which is this transaction amount, not the transaction fee, and this timestamp. These three things, I would say, these three things are included. Okay. Yeah. These three things are included. And what happens is the server, here I'm talking about the signed message. Okay, how is this signed message getting created? So the server takes all the three things and it creates a hash. It creates a hash with the help of, sorry, I will use text here better than this, right? It creates a hash. It creates a hash with the help of SHA-256 algorithm, right? So let's say we did talk about this, how a hash is created. So hash is created, and then what happens? on over of this hash, this particular string, let's say I think 64 byte string, which is a 256-bit string, right? Over this hash, encryption is done. The encryption is done using the senders, which is I would like to use it here. What they do, they create a hash, cool, and then what happens? There's a function going on, right? They use yeah, they use the sender's private key. That's why I was saying that the sender's private key is very essential to send money. Why? We will just see that they use the sender's private key, which is a key, and then they encrypt this. They encrypt this particular hash. Encryption of this hash. If you don't know what is encryption, encryption is something, if with the help of private key, I can change what this hash looks like, and then with the help of the public key, which is available all over the internet, I can also decrypt it and see, with the help of the sender's private key, I can make this hash look something very different, but with the help of sender's public key, I can decrypt this again and make this again the hash. Okay, how is it used? We will have a look on this later. Okay, so do we have an eraser here? Yeah. So this is how the hash is created. I will keep it up here. This will be necessary. Cool. So what this is nothing but the signed message. This particular thing, which gets created. One minute. This particular thing, which is nothing but what is a signed? I will write it up here. What is a signed message? Signed message is nothing but encrypted hash with sender's private key. And here the private key is very important. If you share your private key with anyone would be able to sign this transaction, and hence it is valid. And that's why you don't share this private key. Now, this signed message, I hope you understand what is this signed message. After this entire thing is getting is created, now what happens? First of all, don't take it as a Web2 thing. This is a different protocol. Okay, this is a different protocol altogether. If you don't know what a protocol is, so let's say HTTP is a protocol, the way of communicating. If on a very basic level, I try to say a way of communicating. So this entire Bitcoin thing uses a BTC protocol. Okay, this is not like HTTP2 or WebSockets. No, this is a WebRTC. This is a totally different protocol. What happens after this? After this, I will tell you. Just give me a moment. Yeah. After this Binance server, please try to understand. This Binance server, this Binance server or whatever you will use is connected to a Bitcoin network. This via a software, okay? Via a software, which is the Bitcoin software you can get. It is connected to Bitcoin network. Okay, this is connected to a Bitcoin network. This Bitcoin network, it is already connected. Okay, it is not like a new connection is made. It is already connected to this Bitcoin network. This Bitcoin network has people connected to it. If you remember that the people are connected, if you have heard of word like nodes or miners, specifically people who use a lot of machine, right? A big machine, big let's say sets of graphic card, they are connected to the Bitcoin network. So this is a software. Okay, this is a central software. Let's say this is the network they are connected to via software. So what are they? There are miners. Okay, I will put miners here, let's say. Okay, so these are miners and nodes. There's a huge difference between what miners do and what nodes do. Let's consider these are these. I'm talking about all of these. Okay, these are let's move this थोड़ा सा ना इधर, let's move this थोड़ा सा इधर. There are miners and there are nodes connected to this Bitcoin network already through the same software, okay, or might be some different software, but they are connected through the same software to this Bitcoin network. Now let me do one thing, let me reduce the size of this thing, okay, Bitcoin network, and let me create a box here for all of them, and okay, these are miners on the right side, the one I'm moving as of now. These are text miners, not miners, and these are here on the left side, they are nodes. Now, as I already said, I think we are just about to come to the block and then the chain and then the blockchain. First, we are talking about miners and nodes. Okay, so we are here. What is a node? What happens when this node is connected to the Bitcoin network and the server is connected to the to this Bitcoin network via the same software, right? Once the Bitcoin server creates this particular object, so I will start typing everything here one by one so that we can sum it up later. Creates object of data, of required data, right? Then what happens? What does it do? As it is connected to this Bitcoin network, it broadcasts the message. What do you mean by broadcast? It takes this object in this Bitcoin network, and this object, this particular data, when it is received here, all of this data is received or is sent or it broadcast to this Bitcoin network. This is done via the Bitcoin protocol. Okay, so all the nodes, I wouldn't say the all of the nodes, the let's say the close by nodes. Okay, this is done by the Bitcoin network itself. All the close by or the valid nodes, more than one nodes, please make sure of this, more than one nodes, not just one node, is broadcasted this object that hey, we have a transaction to do, right? So we have a transaction to do, so I will write it up here. Then what happens after the object is created? This object is broadcasted to the BTC network, or from where I would say, from where the nodes can pick this transaction. Why do they pick? We will come to this just now. Cool. Now, once this data is broadcasted to all the nodes or required nodes available, what happens? Let's now take this node as here. Let's say one node. We will talk about what does one node do. Okay. Yeah. So we are talking about what does this one node will do. This node, as soon as it receives the transaction, it does certain amount of work. The work, see, the work of the node, the task of a node is to validate the transaction. What do I mean by validate a transaction? That means he checks, or the node checks, that is the transaction, the requested amount is valid. That means the sender's public address is valid. The correct sender is sending the value. The correct sender, or the actual owner, is sending the money. Does the sender has adequate amount of money available in their account? And the fourth thing, does the person who is receiving this amount, is it a valid address or not? Okay, so what does it do? What does validation of this transaction mean? Is it checks for few things. First, is sender a authorized sender? That means, how does it do that? How does it do that? Checks or the authorized or the sender is authorized with the help of this private key, and hence this private key is very important. But we will see how it is done. Let's continue here. Next, it checks if the sender is authorized, then checks if sender has enough money, right? And then it's check if receiver address is valid. This is what a validation process in a nutshell does. How does it does? Now we will talk about that. Okay. let's say I will move this shit here, I will move this thing here, and then this is a node. So let's do a node here. Okay, इसको size में बढ़ा सकते हैं क्या? Yeah, this is a node, right? This is single node. These are groups of node, and we are talking about this one node. So validating the transaction, is sender authorized? How it is done? Now this is very important, and you should understand this. This is a basic, right? Now you will know about how this sender's private key is important, how this sender's public key is important. And for this, you should already know what is encryption and decryption and hashing, okay, and how they are different. Now we will talk about how the steps are done. So this is nothing but a very let's say blueprint. We will talk about exactly how it is done. First, if you remember, we get this data, right? We get this entire data. I will just copy this up and paste this data here, right? We received this data, or we have this data. Now what happens? What happens if you do remember signed message? What is it? It is nothing but hash of all three, and hence it is decrypted, and then it is encrypted, and that is what signed message is, right? So all of this data. So the first step what the node does is, first it, see, how was the hash created at the first phase? If you remember here, how was the hash created? The hash was created with SHA-256, right? So SHA-256 is available all over the internet. It also does the same thing. It creates a hash. Okay, it creates the hash with SHA-256 of the same data that was used by Binance server, correct? So basically all of these three data is used to create a hash again. So the same process that was done here, this same process is repeated here. Now what does it has? It has a hash of all three, right? Now please try to understand that it also has a signed message, right? Signed message with the help of with the help of what it was signed? It was signed with the help of sender's private key, which is not shared all over the internet. But now what it does is nothing but sender's public key it has. So if you do remember here, that a message can be encrypted by the server's or by the sender's private key, and it also can be decrypted by the sender's public key, and hence when you decrypt it back, it becomes the same hash, right, from where it was encrypted. So what it does, it uses, or I would say, yeah, it uses, what it does, it creates a hash, and then it decrypts the signed message. Sorry for the spelling. Signed message. It decrypts, I think it's CRY. Yeah, it is signed message and creates back the hash from the signed message. समझ गए? I mean, I hope you understand here. It decrypts back. Now, once it decrypts back, what do we get? What do we get back from here? We get the hash. And we have also created a hash from here. Now what it does, it compares. It compares the hash. It compares the hash from the it compares the hash created here in this particular node, and the hash, or I would say the hash we got from decrypted signed message. And if it's exactly same, then the transaction is valid. Transaction is valid. And if not, then it's not valid, right? So this is how it is done. I hope you got what happens. I will sum it up things till here and keep this end this video here, and we will go to the part 2 of this video. I will create a next video out of it. We will just summarize it up here. Till here, what happened? What we wanted to learn till now. What is a block? What is a chain? What is a blockchain? What is a node? What is a minor? Till now, we have learned what is a node, right? But for understanding what is a node, right, and what does a node do, we learned a lot of things. What did we learn apart from this is, first, how what data is sent. I would 1 minute, इसको यहाँ पे लेके जाऊंगा, and opacity small. What data is sent from the server or the actual, what is private key and public key, then how the node validates the data. Cool. This is what we learned apart from this, and now I hope you understand what is a node. In the part 2, we will cover what is a mine, what are miners, right? What are miners, and how this block is created, right? How this block is created, what is this chain, and what is this blockchain. We will also come across a very interesting, I will also create a separate video for what does actually this node do. If this is very confusing here, this is very confusing here, we will create a diagram that how we get a hash, how we get how we decrypt the hash, this decrypts the signed message, and then how we compare, right? And yeah, that's what it is. And after this, once it is validated, in the next video we will talk about what happens after this node is validated. Cool. So yeah, that's all for this video. We will continue this in the part 2. Thank you so much.